Let's dive deeper into the relationship between electricity and magnetism. We've previously looked at how a current will produce a magnetic field and how this can interact with another magnetic field and produce a force. But there's another cool effect that we can investigate called the generator effect. So let's start off with a magnetic field like this. Here we can see a north pole and a south pole, so there'll be a magnetic field going this way. Now, if we take a wire with no current moving through it yet, but it does need to be a complete loop of wire. It's a plain old loop of wire, and we're going to move one part of that loop through the magnetic field like this. That is going to cause a current to start flowing through the wire. The current only flows while the wire is moving. So as soon as we stop moving the wire, the current stops flowing. The size of the current depends on the strength of the magnetic field, and it also depends at the speed that we move the wire through the magnetic field. Reversing the direction that we're moving the wire through the magnetic field reverses the direction of the current. So this is called induced current, or induced potential, or the generator effect. Now, in the energy resources video, we saw that most of the ways we use to generate electricity involve something turning a generator. These generators are named after this effect. They're named after the generator effect. So how do these generators actually work? Well, we get a loop of wire in a magnetic field and we turn it. That will produce a current. It will produce opposite currents in both sides of the loop because they're moving in opposite directions. Then once the loop gets about halfway round or upright, 180 degrees, however you want to call it, looks like this, then the contacts that are touching that loop will swap over. So as it continues to move around, the current will be in one continuous direction. This is a DC generator. It's inducing a direct current flowing in one direction only. If we actually didn't have the contacts swapping over like that, then the direction of the current would reverse every 180 degrees. We'd end up getting an alternating current out. So we can also have AC generators. Another place that we use the generator effect is in microphones. So inside a microphone, there's a tiny little rubber thing called a diaphragm. That is going to wobble whenever sound waves, pressure waves, pass over it. So just by speaking into this microphone, you're making a little rubber thing wobble. And we attach to that rubber thing a coil of wire. And next to it is a magnet in a fixed position. So when you speak into the microphone, it causes the diaphragm and the coil of wire to wobble around the magnetic field. That produces a current, and the current will change direction at the same rate that the diaphragm wobbles, which is the frequency at which you've spoken. So we end up getting an alternating current coming out of the microphone at the exact same frequency and relative amplitudes as well as the sound that went in. So that's how microphones can turn a sound wave into a digital signal. Very cool, very interesting. Yeah, the generator effect.